Okay, going over lab assignment number 4 for you guys. So this is all mostly straight beam stuff until we get to the bottom. So let me break it down to you. For the first assignment, a straight beam transducer will be used. Using the round steel block, set the transducers to 80% on the block with both sides smooth. Indicate the percent height for the other blocks. So we got blocks that are smooth top, rough bottom, rough top, smooth bottom, rough on both sides. So this is one part of the lab there. Just going to put a line through it. Of course, this is straight beam. Second assignment on this one is using a 1-inch block on the vertical axis for this experiment. Indicate gain for each decibel of the following couplets. So we're going to be messing with a few different couplets on this one. Set the first back reflection at 80% screen height. Indicate the decibel reading for each of the following couplets. So you got cellulose gum water, which is the couplet that we use. We got vegetable oil, motor oil, and water. And this is also a straight beam. The third assignment on this, couple 4 different coaxial cables and transducers, same size of megahertz, and note the difference on decibels. Set each to 80% screen height. So that's the fourth activity. The fifth activity is using different size and frequency transducers. Note their difference in amplitude, signal, and decibels. Set each of the first back reflection to 80% screen height. So we're going to get different transducers. So you got 4 different types. 1, 2, 3, 4. You're going to note the decibel on here of what it reads, and you're going to note the megahertz reading. You can find the megahertz reading on this on the information on transducers there, and we'll get to that in a bit. This is also a straight beam. And for the fifth one, to see attenuation difference in materials, draw 2 curves and back reflections, one from 1 inch of steel and one from 1 inch of plastic. So that's the fifth one. The sixth exercise is calibrate to AWS for distance and sensitivity and scan a mock weld specimen. Draw a map, top view, of the specimen showing the indications in relation to the weld and indicate the depth and length of each. So this one is done with shear wave. All right, so let's do the first one. First assignment is the one with the 3 blocks. And we've got these 3 sets here. So like other labs, you'll have to go back and forth and share these. Let me turn on my UT machine here. Get that in the screen. Take the lab sheet out so it doesn't get crushed. Let's go ahead and fold it. So here's the UT machine. Before we get started, we want to check our settings like what we did last week. Make sure our machine is calibrated. So I want to go to probe angle. Go back. Set that to 0 because I'm using a straight beam. Okay, that's 0. Now I'm going to go over to set my velocity. To mild steel straight beam, which is 0.2323. All right, now I'm just going to calibrate the machine first. Using regular couplet. Got a DSE block. Keep in mind of the side cut there. Dab a little bit of couplet on there. Got my transducer hooked up on my cable. Put that on there. Oh, way too much gain. Turn that down a bit. As you see, I got a 10-inch range on the screen. Just turn it down. I want to get it to 80% screen height on the first back reflection. Also, I'm going to take this off the block and verify where my... There you go, that's the initial bang. Move that over. And now there's my first back reflection. Nope, turn it down some more. Okay, now I'm gonna move my gate over. See the gate there, move that gate over. Gate width, I'm gonna shorten it up a little bit. Gate start, bump it over. Gate threshold, put it 80%. Okay, that's 80%. I'm gonna move my probe delay over until I get a 1-inch reading on there. Okay, there it goes. Reading is a 1-inch. Okay, now I'm calibrated. So we got these blocks. This one is, let's see, rough on both sides, it seems like. This one's definitely rough on top, smooth on bottom. And this is both sides smooth. So what you're gonna do, per the instructions, so you got a smooth top, rough bottom. Smooth top, rough bottom. So let's go back on this one, 80%. If we move our gate, it will tell us the depth of this block. Just here under 2 inches. Okay, notice how this one pops up. Next, we're gonna go to rough top, smooth bottom. So I'll take this coupling off of here. Rough on top, smooth bottom. And notice the difference in the reflection. Notice how high it goes compared to the other one. Then we'll go to the next one. Let's grab more coupling, try to scrape this off. Rough on both sides. This is rough on both sides. And notice, indicate the, or map out the back reflection on that. I'm gonna try the other side. Get some coupling. And this one is so rough on this surface that it's barely giving me an indication on that. So note them on where the indications fall. As far as for percentage of screen height and the back reflection. And you'll note that on this area here, here, and here. Okay, let's move to the next one. So this one here, we're using a 1-inch block on a vertical axis for this experiment. Indicate the gain in decibels for each of the following couplets. Set the first back reflection to 80% screen height. Indicate decibel readings at each of the following couplets. So we're going to be switching our couplets. So back to this DSC block. Check our calibration. Check our gate. Yeah, 1 inch. So now I'm gonna wipe this coupling off. So we got glucose gum and water, which is regular couplant, like this. We got vegetable oil. We got motor oil. And we have water. So you can go through, I don't want to make a mess on this table here. Pour some on there, put the probe, check back reflection, and see where it indicates. So I'm just going to do one with the vegetable oil. Let's do the water. A little easier to clean up. So we had an 80% screen height on this one. Let's see what the water does. Shouldn't be too much change. Oh, quite a bit. So we're pretty much max out 100% screen height on the water. So no gum to attenuate the sound. So you mark that for water. You mark the percentage. We got a little bit of vegetable oil here. Drop that in there. Oh, we got a little more back reflection than we had on glucose. It's losing the signal a little bit. So note your findings on vegetable oil. Let's do one of the motor oil. If you're wondering, this is 5W30 weight. And note the back reflection on the first one. And note that on your sheet there. Okay, that's second assignment. Third assignment is couple 4 different coaxial cables and transducers. Note their difference in decibels, each 80% screen height. So what you do with this one is keep your same transducer that you're using. Keep this guy. Change out the cable you have now. For some of these other cables we have set out. We got ones that are definitely not going to give you too much as far as the signal return, and we got some that will give you just the right amount. So change them out, plug them back in, plug them back in the machine, and read the findings on that. Next assignment, using different size frequency transducers and note their difference in amplitude, signals, and decibels. Set each for the first back reflection at 80% screen height. So what you do on this one, use what you got on your machine. Set it to 80% screen height. Then go get a different transducer that has a different frequency. If I can read this one is, get the light on this one. This one I have here is, I believe, is a 2.25. This is probably a 3.0. What you do is switch it out for this one. Of course, plug it in, and then turn it up until you get 80% screen height. As far as we're turning up your decibels, record your decibels per each transducer on here. So you record the megahertz of the transducer you're using, and how many decibels did it take to get your 80% screen height. The last one for straight beam is use, let's see, get this in focus here. See attenuation difference in materials. Draw two curves from the back reflection from 1 inch of steel and 1 inch of plastic. So we'll do straight beam again. So get your back reflection on the steel. Note the back reflection on that. Draw these out. Then switch over to a plastic block. It's also 1 inch. And note the difference. And the last one on here would be something that we did also on the last one. You guys get you're gonna have a lot of experience in this. Is calibrate the AWS for distance and sensitivity and scan the mock weld specimens. Draw a map from the top view of the specimen, showing the indications in relation to the weld, indicate the depth and weld length of each. And while I got you guys here, let me show you how to draw the map. I think that might be something that's helpful. I don't have a weld specimen here in my office, but we'll go ahead and use this IW block as a specimen. A little bit of imagination here. Of course, I'm going to switch over to a shear wave. I'm going to set all the configurations I need on my UT machine, on my flaw detector, to say 70 degrees. I'm going to calibrate it, as you see on the previous calibration video. And I'm going to shoot this thing like it was a weld. So if this is my weld joint, let's call this the weld here. I'm shooting this thing along the weld. I find an indication, I find a flaw. And to map it out on the back of your lab sheet, it should look something like this. Draw the specimen, in this case it's an IW block with a pretend weld in the middle. We'll call this the weld. So you want to find, if you find indications here and say here, what you want to do is come from center line of the weld here, draw a line from a dimension on this side. Let me move this page up a bit in the frame. Indicate how far away from the center line of weld is this indication. Next area to put dimension to is the length of the weld, or length of the flaw that you found itself, to the outer edge of your plate. That way it gives us information on how far and where it's at. Say this is, say, 1/2 inch. For easy sake, this is also 1/2 inch, and that's also 1/2 inch. And you want to mark the depth indication. Say this is a 1 inch plate, or it is a 1 inch plate. The indication is that if you say it's 1/2 inches down, 1/2 inch down, you minus half. That's how we want you to mark it. So same thing on the top side, you find the one there. Center line of weld. And say this is 1 inch out. You want to do the length of weld and from edge of plate. Put a hole in this paper here. And for sake of easiness, there's 1 inches. And the length is also 1 inch. Depth on this one, no surprise. Found it at 1 inch. So this is how you map out indications on a weld. Weld joint, center line weld joint, edge of weld, or edge of material, flaw location, flaw location. And that concludes tonight's video.